Hello, everybody, and welcome to another episode of Dome to Home. How's it going, Rémy?
Hello. I am doing fantastic, Jeremy. I'm really excited to be here. I am back. So last week, Tara was here. This week, I'm back. I'm excited. So if you've watched before, you should be familiar by now, but in case you have forgotten or didn't hear just a second ago, my name's Rémy. I'm an astronomy student at University of Colorado Boulder, and I'm a presenter at Fiske Planetarium. And below, as always, we've got...
Yep, I'm Jeremy. Hello, everybody, again. As a reminder, I'll be the navigator, so I'll be flying everything that we are seeing live, doing all the back end. And we've also got Tara with us, hanging out as our question master over in the chat. So if you guys got any questions, I think she provided a link for you guys. You could type those questions in, and we'll be checking those live. That's about all from my end, Tara. Or Rémy and Tara.
My name's Rémy. Yeah. So, yeah, as Jeremy said, questions in the chat. There's also the pinned comment. Last week, we had a little bit of trouble getting the live questions from that comment survey, but we've got it fixed this time. And the questions from last week, I'll be sure to address those as we go. And we also added them as a comment on last week's YouTube video if you're too curious to wait. But anything you send in the chat or submission form, Tara's going to tell us, and we'll answer them live on the show. And then we'll also have time at the end that's devoted completely to questions. So. Awesome. As you've seen, this month's topic is exoplanets, or planets that are outside our solar system. So a few people last week asked how many exoplanets there are. And while we have discovered and confirmed over 4,000 exoplanets, which is a lot, and there are thousands more candidates, estimates say that we could have billions of planets just in our galaxy alone. So billions of exoplanets in our galaxy, billions of galaxies. There's a lot of planets. So we have 8 planets here. So 8 of those billion are our planets. And they're going around our sun along with some dwarf planets and moons, and they're all fascinating in their own right. And there's a lot of variety there. But with those thousands of other planets that we know of and the billions more waiting to be discovered, so surely there must be some weirder ones out there, right? Let's take a look at some of those really, really weird exoplanets. So let's hop right in here. With one of the most easily found types of exoplanets. So we talked about them a little bit last week. Those would be hot Jupiters. So if you remember those, then awesome, you've got a head start here. But a hot Jupiter is basically a planet whose size is comparable to Jupiter, like a really big gas giant, but it's really, really close to the star, making them hot. So hot Jupiters. Sometimes astronomers come up with some really cool names, and sometimes they just call it like it is and phone it in and call it good and go home. So hot Jupiters. So these planets orbit their stars in a matter of hours. That's how close they are. Because the closer you are to the sun, the faster you're going around. And they're just unbearably hot. So they're so hot that their atmosphere is being stripped away by their stars. You can see in this awesome picture Jeremy has pulled up. So it's almost like a comet with the material being blown off. So often these planets are also close enough to be what's called tidally locked to their stars, which means the same side of the planet is always facing the star. Kind of like our moon is tidally locked to Earth, we always see the same face. So that means that many of these hot Jupiters and other planets extremely close to their star have one side in perpetual day and then one side in perpetual night.
Yeah, and one thing that's pretty cool about that is it also means that if you think about it, there'll be a ring around that planet where it will always be either sunrise or sunset, depending on which side you were on. So I think that'd be sunstay. That's right. So I think that'd be kind of cool to think about. Probably be a pretty expensive piece of land if you wanted to get a house in permanent sunset somewhere, but it might be a nice place to have a vacation home or something.
It's a fancy vacation spot. So one of the questions that we missed last week is how can a gas giant be so close to its sun? Because it doesn't work here like that in the solar system. And that person is right. Our solar system doesn't work like that. We don't have a big gas giant right next to our sun. And when you learn about planet formation, turns out gas giants do form far away from their star. They are far from their star, and it's nowhere near where these hot Jupiters live. And that was really a big mystery to scientists when we, first discovered all these hot Jupiters. So our ideas on planetary formation aren't really set in stone. We've got a pretty good idea, but it's pretty easy to toss a huge wrench into tenuous ideas, and this was a huge wrench. So we've got an idea, though, on how this might have happened, on how they could have migrated inward. They form further out, and then planets can interact with each other. Their gravity can interact with each other, and they get moved further out or closer in. I can use hand signals there. So you can see here, one went flying. So this happens over the course of like millions of years. So it's not like one day you're out at Jupiter's orbit and then the next day you're just careening into the sun. It's all about those gravitational interactions between stars and gas giants. And this didn't end up happening the same in our solar system, as you can tell, because Jupiter isn't next to the sun. That's probably because there are other massive planets like Saturn stabilizing its orbit. So our Jupiter stabilized further away. Meanwhile, those other Jupiters weren't quite as lucky, ended up real close. So we found a lot of these hot Jupiters, which would indicate that these planets that we thought were super bizarre are actually really common. But you do have to be careful with that because they're also, as I said earlier, the easiest types of exoplanets to find. And next week, we'll talk all about how to find exoplanets. And you can find out why that is. But because of those methods, if it's easy to find, we find more of them. So we don't know 100% that these are as common as they're showing. So in addition to these hot Jupiters, we also have super Earths. So these aren't necessarily like a better Earth or anything, depending on how you look at it. And in fact, many of them might be nothing like Earth at all. So this term just applies to planets that are more massive than Earth, but are much less massive than, say, like Neptune or Uranus. So these could be anything from a really small gas giant or an ocean world or even something rocky like our own Earth. And if that one's cooler than ours, then cool, that would be a super Earth. But not every rocky planet is actually made of the same stuff as our Earth. So scientists theorize all sorts and types of planets out there. If there's an element, someone's considered a whole planet made out of it. So composition really depends on what elements were available in the nebula, the gas cloud that made the star system. So our planets in the solar system are made out of what was here, and there are other nebulas out there with slightly different compositions that can lead to some really different planets. For example, we could end up with a diamond planet, like our video title, a diamond planet. And that's a crowd pleaser. So imagine a diamond as large as a planet. So diamonds in and of themselves aren't really anything all that special. They're just carbon with molecules arranged very specifically, usually by pressure. So if you have a planet that's composed of enough carbon and you've got that pressure from gravity, you can effectively have a planet made of diamond because of that gravity. So scientists have actually discovered a planet like this. It's not just an idea someone had and threw out there. So there's this planet. It's mostly made of carbon and silicon. This one is 55 Cancri E, I believe. There it is. So planets aren't just rocks or gas, though. We've also got, as I said earlier, ocean planets. We've got water worlds.
Yeah, so we'll go ahead and take you to one of our ocean planets here. And let me go ahead and show, it's one of the earlier exoplanets that was discovered. Show an artist representation of it right here. This is a planet called Kepler-22b. So I know for other Star Wars fans like me, it maybe looks something like Camino, or you can imagine a planet that would be just a total, completely covered ocean, a planet completely all water. Now, this obviously, could only depend if this planet is in what is called the habitable zone, which is what Rémy will get to a little bit later. But although we do have these water worlds that we're finding, these super Earth water worlds, if these planets are actually further away from their star, we would think that perhaps they would probably likely be a lot colder. And in that case, we might end up with a planet more like Hoth. So this one, It's not the greatest artist representation, but you could think if there was an ocean and then maybe that planet moved away from its sun and everything froze, or if it was just frozen from the get-go, you would have something like Hoth. This is the planet aptly named Ogle 2005 BLG 390.
Naturally.
It's quite a mouthful, but sometimes, as Rémy said, we have good names and we have bad names in astronomy. I would say this is it's a little bit harder to remember. But one unfortunate thing about this is that it is so cold that on average it's like minus or negative 390 degrees Fahrenheit. So if you were going to hope to ride some tauntauns around and relive or act like you're in Star Wars, this might not be the best place to do that.
I would not recommend it. I like the cold, but not this cold. But whether it's an ocean world or an ice world, or if it can even have water at all, like Jeremy was saying, it depends on temperature. Temperature just plays a huge role on what a planet might be like. The closer you are to a star, the hotter, and the further, the colder. And if a planet is too close to its star, instead of something like Hoth, you can end up with something a little different, a really interesting planet to say the least. So you've got those hot Jupiters that I described before with their atmospheres being stripped away. That's one example. But you could also have a lava world, which would be a rocky planet so close to its sun that it's completely molten. You could even have weather where it rains titanium or molten iron.
Yeah, so this is another really interesting, pretty hostile planet. This planet is called K2141b, and it is so close to its star that all of the iron and basically all the silicates and material that are on the planet, on the surface, on one side of the planet, is always just liquid magma. The planet is tidally locked to its star, so it means it's always facing the same side. So on that side that's always facing its star, the temperatures soar. All of the magma and everything actually evaporates, just like how water, like the oceans evaporate here on Earth. Those magma evaporates get carried up into the atmosphere and blown over to the cold side, the nighttime side, you could say, of this planet, where the temperature then drastically decreases and it actually rains magma, or it's raining rocks on this planet. So a very cool planet to think about. They basically have a rock cycle like our weather, or like our rain cycle, but definitely not one that you could go and live on.
It'd be cool to see, though. I'd want to see that personally.
I would definitely want to see that.
And all this stuff, it sounds really wild. But, could our own Venus, with its hazy sulfuric atmosphere and unbelievably hot surface temperature, be just as wild to someone who hasn't seen anything like it? A lot of these wild planets are more common than we think. We find more and more of these weird ones. And it's looking like we might be the oddballs. I guess it depends on what your perspective is. And as much as astronomers love to find these strange planets, or planets strange to us, we are also, absolutely drawn to finding similar planets, especially if you're hunting for life in the universe. So we want to look for the next Earth if we're looking for life, because it's the only planet that we know for sure has evolved life. So we want to look for things that Earth has. So the number one thing that we're looking for is liquid water. So let's say we want to look for that, for liquid water, a necessity for life as we know it. You need to be just the right distance from a star. And that's what we call, as Jeremy mentioned earlier, the habitable zone, or sometimes the Goldilocks zone. Not too hot, not too cold, just right. We want to make sure our porridge doesn't get too cold. So different type of stars, they also have different temperatures. So this habitable zone is different for different types of stars. It's not necessarily that something as far away from their star as Earth is going to be in the same habitable zone. It might be too cold for a dimmer star, or a star that's not as hot, or it might be way too hot for a star that's really hot. So we can actually compare our sun to, oh yeah, here we go. We've got it to some real life stars over here. The hotter star, you can see it's much further out. You have to be a lot further away to be in that habitable zone. For the cooler stars, you can be a lot closer. And we can take a look at a real example of this, actually.
Yeah, so we're going to go hop on over to a star system called TRAPPIST. This was in the news a lot. I'm sure many of you guys have heard of it, maybe. And as I'm flying us over here, let me show you why, one of the reasons why this got so much attention. So the TRAPPIST planets are orbiting a star called a red dwarf, which, if you see here, is that little red star, little compared to our sun, which is that star there in the middle, and then you have some larger blue stars towards the right. And so, as Rémy just said, with what that means for the habitable zone is that these planets can be a lot closer in. So let me go ahead and show us our TRAPPIST system here. Go ahead and get it over here. So here we are looking down. They've found 7 planets in this system, all within the orbit of Mercury. So you might think, oh, it's going to be way too hot, but since it's a red dwarf, it's a much cooler star, so it allows for these planets to actually still be in the habitable zone, even though they are that close to their star. Let's see if I can enlarge these planets a little bit and give you a better sense of what is going on here. And so you can see it's almost like a perfect bullseye here. Sorry, I'll remove this this patch in the back for us. That's the Kepler field that we looked at last week. But here we see all of these 7 planets going around the star. I think the inner 2 or 3 are probably going to be a little bit out of the habitable zone. And then I think, what is it, G, E, and F, Rémy, that are in the habitable zone? Here we go. Here's
yeah, something like that.
Yeah, so here's
I wrote it down.
Yeah, here's a comparison of basically the TRAPPIST system habitable zone to Earth's system. So here on the bottom we see Earth kind of right in that green spot. Mars is kind of right on the outer edge, and Venus is right on the inner edge. TRAPPIST, you see there's that one planet way out in the boonies, out where it's probably a little bit too cold, but then you have 3 planets that are probably good candidates for looking for liquid water on the surface. And so that's why it's so exciting, because they're also really close together, and they think maybe if life had evolved on one, then maybe they could have been on the other ones. It's definitely one of the more exciting exoplanet systems that has been discovered.
Yeah, this is super exciting. All of these are rocky planets, and you saw they all fit within the orbit of Mercury because its star is just that cool. You can have planets orbiting, all types of stars, like we saw our sun, and we've got this red dwarf here. But you can also have planets orbiting multiple stars, like Kepler 16b, actually right behind me on one of my fancy posters over here. So Kepler 16b is orbiting what's called a binary system, a binary star system. And it's kind of like a pair of stars, 2 stars that orbit each other, and it's very, very common. In fact, binary stars are likely more common than a single star system like our own. So having a planet with 2 suns isn't too outlandish, actually. You can also have planets around 3 stars as well. Someone asked about that last week, or even more. It's a lot less common because the orbits are more difficult to stabilize with so many massive stars. Whenever you have more than 1 star, you can have a variety of orbits. You can have a planet that orbits just one of the stars. You can have it orbit both of the stars in a binary system. If you've got like a trinary system, it's really tough to get those stable orbits. It's usually just going to be around one of the stars, but there's just so much mass and so much gravity interacting with each other. It just gets wonky and it doesn't go very well. But Kepler 64 is an interesting case. It's actually orbiting 2 stars around a pair of 4. It's like 4 stars and it's orbiting 2 of them. It's really neat. So yeah, this picture doesn't look very happy about being the planet of 4 stars. I would be excited about that. These aren't the weirdest things that a star could be orbiting, or I guess it depends on what you think is the weirdest thing. But Tara talked about what I think is a very strange thing for a star to be orbiting, and that would be a pulsar. And that's where the first exoplanets were found. If you're curious about that and weren't here last week, I would definitely recommend watching that video because Tara had a lot of cool stuff there. It was a really bonkers discovery because pulsars are the remnants of dead stars. So one of our questions last week that I missed was, can neutron stars have planets and would they have a habitable zone? And I'll go ahead and address it here because a pulsar is a neutron star. And that's what's left after a supernova explosion of a really massive star. So these huge supernovas, and there's a planet around it somehow. So how do these stars keep their planet? Turns out they probably don't. These probably aren't the same planets that they might have had before their deaths. It's likely that these were actually created from the remnants of the supernova that left the neutron star or pulsar in the first place.
Yeah, so here's a nice example. Obviously, it's just an artist representation, but here on the bottom, you can see those two brighter points of light. You have one that has the two beams coming out, so that's the pulsar. And what's interesting about this planetary system is that it's a binary with a pulsar and a white dwarf. So two kind of end stage stars, basically. And then there's this other big planet, and it's one of the oldest known exoplanets. It's actually been estimated that's about 12.7 billion years old. So that is very, very old, and it's orbiting a very weird binary system. So I don't know. I like to think that maybe this is definitely something like a planet that maybe got kicked out of its old system, and then somehow, you know, got gravitationally interacted with this weird, odd coupling out there.
Yeah, no, it's a really weird one because not only do you have the neutron star remnant, you also have this white dwarf, which is a remnant of a smaller star dying, and then you've got the binary pair, and then you have a planet orbiting the binary pair. It's a lot. But before you think about picking up and moving to one of these planets, as cool as they seem, you might want to reconsider because it's highly unlikely anything could live on these planets due to the extreme radiation they're receiving from their star. It's almost certain nothing could have evolved on a planet like this or anything new could survive there, making these planets really, really cool, but also entirely sterile. I wouldn't vacation there personally. So yeah, you can have planets around a neutron star, but no, they don't really have any sort of habitable zone at all. So we've had these huge planets orbiting close. We've had weird planets that are orbiting all over. We've had planets around red dwarfs, multiple stars, deadly neutron stars. But, and Jeremy mentioned this a little bit, what about planets that don't orbit anything? Because it does turn out that there are exoplanets out there that aren't even orbiting a star. So when you think about planets and planetary formation, planets form with their star. So how does a planet end up not orbiting a star? So it turns out that these are planets that were once part of a normal system, orbiting their star, not a care in the world, doing fine, having a blast, until something happened and their orbit became unstable and they were flung right out of their star system. So maybe one of those hot Jupiters disrupted the orbit and just flung it out, or maybe it was around one of those triple star systems that just wasn't stable enough to keep the planet. Whatever it was, these planets no longer have a star and are just out on their own. So we call these rogue planets, or sometimes orphan or free-floating planets. So these rogue planets are understandably difficult to find, not being around a star. Tara will talk about what makes it so difficult next week, so definitely tune in about that. But it's theorized that there are millions upon millions of these just wandering around between stars. Unlike my hopes and dreams of never having to worry about sunburn again, you won't find much living on these planets. For starters, many of them are gas giants. Like, for example, wow, another one of my posters, PSO J318.5-22, another catchy name, as per the usual. And they could even be potentially failed stars. So gas giants, failed stars, and there are some that are rocky and Earth-like. But without that proper energy source, like a star, it's just not going to be able to sustain life. So my vote is it's a neat vacation spot, and I definitely visit a hotel there, but you're not going to find any life, unfortunately.
Mm-hmm.
So I'd love to visit it. Are there any planets that y'all would like to visit? Like any of the planets we've talked about? Because Rogue Planet is my top destination choice. But if there's one you thought was interesting to visit, definitely let us know in the chat.
Yeah, drop them in the chat. I'm very curious. Obviously,
what about you, Jeremy?
Yeah, as you might have guessed, I would really like to go to TRAPPIST. That system would be, I don't know, it'd just be so cool. I think, like, it obviously depend on if there's a lot of snow and ice on that outer planet, but the fact that they're so close, I'd have to do the math on this again, but I'm pretty sure if you were living on planet G and you were to get to H, so one of the G is the one right in the main habitable zone, H is that one out in that, a little bit beyond the habitable zone. I like to think that you could maybe just have like a permanent ski resort out there on planet H, and that would just be like the ski vacation planet. So you could just, instead of going to the mountains for the weekend, you could take a week trip out to planet H and go skiing for another week and then come back or something like that. So that would be pretty fun. What's that?
I think it only goes to G.
Oh, does it only go to G? Did I get my letters off?
I don't know. I was counting over here on my fingers. I'm going to be honest with you here. Astronomers are fantastic at math.
B, C, D,
most
E,
of them
F,
are, not
G.
me though.
H. That's
H,
7. Because A, there's no A because that's the star. So TRAPPIST B is the first one.
Good morning.
E, F, G, H. But yes.
Time for my embarrassment. No, yeah, I would love that. There's like so much to, it's not just like a one trip. You're not just visiting one planet. You've got like 7 of them to hop around. It'd be pretty cool. There's some people in the chat. Ari Sprite likes the diamond planet. That would be pretty neat. I'd love to see that.
Yeah. You could be like a miner, like a planetary prospector, go into the diamond planet. But then I don't know if we would just want to start mining full planets. I don't know.
Be interesting.
It depends.
There's a lot of questions with that. But yeah, now's the promised time for questions. So if you have anything at all that you're curious about, don't hesitate to let us know in the chat, wherever you happen to have that, or in the question submission link, either in the description or pinned in the chat. So definitely let us know if you have a question or have heard of a different type of exoplanet you want to talk about, or if there's a favorite fictional exoplanet that you know of and you want to know if it's realistic, or any space question at all. We'd love to hear. We actually have some already, which is awesome. So we have, could there be a Goldilocks zone around a star that has achieved hydrostatic equilibrium? So how do you mean? Like, does it have water and is okay with water, doing all right? Because it's possible that you could have a planet. So the Goldilocks zone is specifically a place where water is stable. So if that's what you were asking, does that make sense? But yeah, so water can be stable. You can have that A-OK on other planets. We don't have anything one way or the other if there's something specifically like Earth, but there's math that adds up and places that we're looking where it all adds up. So you absolutely could. So have we found any jungle planets? Great question. So we haven't really confirmed life of any particular sort on any exoplanets. But there's only really so much that you can learn about an exoplanet from so far away. So it's possible that some of these planets that we're looking at are jungle planets, some of these rocky ones. Nothing that we've confirmed though. And most of the ones that we see don't seem very habitable, but it's something we keep an eye out for. If we were looking for a jungle planet, one thing we might want to look for is what the atmosphere is made of. So here on Earth, what our atmosphere is made out of is there's a lot of oxygen, there's some carbon dioxide. We might look for an atmosphere like that and think that could be something with plant life, with photosynthesis. So we don't have any 100% confirmation, but be pretty cool.
Great question. I'm just bringing up some of the other habitable planets that we've found right now, as Rémy is doing a good job at answering these.
I think I know what the question was before. The star itself has achieved hydrostatic equilibrium. So every star actually, if it's on its main sequence, we actually have a lot of videos about stars if you go through some of our older Dome to Home stuff about stars. But in its main lifetime, hydrostatic equilibrium just means that the star is not unstable. So your star would hopefully be in hydrostatic equilibrium, because if you're a planet going around a star that's not stable and is really unstable, then you're not going to be able to have life. You could be in a Goldilocks zone, but your temperature might fluctuate. So it's really tough to say if there's going to be any like decent life planets or water planets or anything around a star that's really unstable or dying and isn't in hydrostatic equilibrium. Sorry about that. We do have a question. Are there planets orbiting around a black hole? So none that we know of just yet. It is theoretically possible though. I mean, we had the planets orbiting the pulsar. right? So we've got planets orbiting neutron stars, which is, you know, a dead star, and black holes, the stellar mass black holes, which we have a lot of good videos on black holes as well. You know, we could maybe have a planet going around one of those, but we just haven't found one yet. It'd be really tough because it's really tough to find a black hole because they eat light. So they're not giving off light, which means they're tough to find, which means finding an exoplanet around a black hole would be really, really tough. But there's nothing that says there won't be.
Yeah, I would think we'll probably get into a little bit of this next week when we start talking about our detection methods, because when we were talking about the rogue planets, without going too much into detail, we basically use a thing called gravitational lensing to discover these planets, which basically means we see light pass around the planet, and then we can infer that there's a planet there. So I would think that maybe if there was a planet in front of a black hole and we had a sensitive enough, I don't know, it'd be tough. That'd be tough. We'd have to have a really sensitive, really sensitive telescope.
All I know is it's above my pay grade to find. So
the black holes basically can bend light enough. So if you had some light bend around, I don't know, I'm getting too deep into it. It'd be tough, but I'm sure it can happen.
So we've got HD40307G, hashtag astronomers rename us, please. So when astronomers name things, as you can imagine, naming 4,000 planets would be really, really difficult. You got to come up with 4,000 different names. I guess you could call like some sci-fi writers and they could churn things out for you pretty well. You can just lower your standards quite a lot, but it's just really tough to name that many. So what we usually do is sometimes we'll name a planet after the star that it's orbiting. Sometimes we'll name a planet after whatever telescope discovered it. So planets that are like Kepler, insert number here. Those are ones that were discovered by the Kepler telescope. So those are the main ways that you'll see those names. So when you see all those numbers, they do actually mean something. There was an astronomer there who's just like, I don't know, HD 40307G. So there's a reason behind it, but I would still like some cooler names, personally. In your opinion, what would be the weirdest element a planet could be made out of to live on or not? Man, there are some weird elements that you can make a planet out of. So like I said earlier, if there's an element planets have theorized, no, scientists have theorized about maybe a planet being made out of that element. I think if there's any planet or any elements that I think you really wouldn't be able to make a planet very well out of, it would be unstable elements, radioactive elements, like uranium, plutonium that have half-lives and everything. So by the time it's gone on long enough that you can make a planet, then it wouldn't really be uranium or plutonium as much anymore. Tara says a planet made of mercury would be pretty crazy. That would be pretty crazy.
Yeah, I would say
Mercury, though. How would we differentiate?
I think I would have to say I would be most interested in finding planets that were just completely made of like elements that you don't get, or that elements that are past iron in the periodic table, like elements that we know are pretty much only formed in like supernova. So some of like the more rare elements, if you were to find a planet made straight, like what is titanium? I think titanium is past iron.
What a gold planet.
I hope.
There's
or like
gold
something
in
like
planets.
that was completely made after it. Because it would mean that there would have to be so much time and so many supernova explosions, so many star deaths for there to even be enough of that one element, and it would all have to somehow coalesce together and then actually become a planet. That would probably be the weirdest one for me, because it would be like,
would be weird.
If you found something like that, you would almost, I don't know, it'd be very, very hard to come across something like that in nature. So
yeah, what Jeremy's saying is really true, because you can only really make these elements in supernovas or after stars have died in some capacity, in some manner. So getting enough of that element would be really tough, but you'd know then that it's a pretty young planet.
Mm-hmm.
It should be pretty interesting. That'd be pretty cool. I'm about it. Cool. Honestly, I'm about it.
Another great question. Yeah, you guys are.
And then as far as living on it or not, no, I wouldn't live on any of these planets.
You don't want to live on a radioactive planet?
Not really.
I don't know. That'd be kind of cool.
That'd be interesting. I'd love to study a planet like that, but
Yeah.
I don't think I'd want to live on any of these planets. I'd go mine a gold planet, but only if no one else knew about the gold planet.
Try to get rich mining some planets.
Yeah.
Yeah.
My get rich quick scheme.
Mm-hmm.
Go fund my rocket to another planet that we haven't discovered yet.
Yeah. That kind of makes, so another thing I wanted to mention, when we were talking about the planets that are orbiting pulsars, we said that it wouldn't be very fun to live there because of all the radiation and it's a very sterile environment. But depending on if how much of the planet has survived after, or just by the time it gets there, it might make for a really cool display. Especially if there is any type of magnetic field left in the planet. I know this is very, the research on this is not out yet, but people are starting to search for moons around planets. And I know with some of these bigger hot Jupiters, there's, thoughts that a lot of these probably do have magnetic fields. And so there would be aurora if they had a moon like Io is to Jupiter. So if these exoplanets had some sort of, moon that was, spewing a bunch of material back down onto the planet, and then it was also orbiting a pulsar and getting bombarded by all this other high energy material, it might be fun to fly your spaceship by and, watch the light show for a night or something, and then get out of there before you get really deformed or something. I don't know.
Got some cool exomoons. That'd be neat. Sci-fi writers out there, take some notes about these exoplanets. I want to see this cool stuff sometime. I want to see a cool pulsar exomoon aurora in my next sci-fi movie. But that's all the time we have today. If you have any other questions, feel free to submit it in that question form, or come back next week when we're talking more about exoplanets. We're going to be talking about how to find them. So that'd be really cool. I really had a great time with you all. I really loved it. And I'm super pumped about this new season of Dome to Home. So be sure to come back next week. Same time, same place, 3 p.m., Fiske's YouTube channel. Come see Tara. And if you enjoyed this video, don't forget to like it and send it to anyone you think might also like it. And then subscribe to Fiske Planetarium and hit the little bell so you can turn on notifications for more videos like these. Yeah, from all of us here at Fiske, thanks so much for joining us.
Yeah, thank you very much, everybody. We'll see you guys next week.
Bye.